So the other day I looked at using pusher WebSockets in a Lucee CFML application to push events to the browser. But I talked in that post about using WebSockets as a nice to have, meaning something that could progressively enhance an application but wouldn't necessarily be required for a good user experience. Which made me start to think about, well, what can I do if my WebSockets fail? Well, if I'm not pushing data to the client, I have to start pulling data from the server. And one approach to do that is a technique known as long polling. Now, long polling is not necessarily a great technique because it holds requests open, which can theoretically lead to thread exhaustion if you have a lot of long polling requests running in parallel, but I think this would be a fun thought experiment. So what I'm going to do is simulate a long-running task, and the browser here is going to be using long polling to check on the status of that task. So let's look at the server-side component first. So the long polling implementation on the server side is going to be using Redis's blocking list operations. And in this case, we're going to be using the blocking left pop, which is going to look at a set of lists located at the set of keys here, and it's going to hang for a certain timeout. In this case, we're going to say it's going to hang for up to 3 seconds waiting for an item to be available on that list. So this request that comes in is going to provide a poll ID, and then we're going to get a resource from Redis. We're going to ask Redis to block and wait for 3 seconds while looking at this list, and you can see that the key for this list is based on the poll ID coming in. We're going to block for that period of time, and then if the result from that blocking operation is non-null, we're going to go ahead and return the payload from that list item, which gets set here in the results. And if the results are null, we return a 404, and if they're not null, you can see we return a JSON response. So again, this is the endpoint for the long poll. Because the Redis request here is a blocking operation, this overall request will also essentially be a blocking operation. And if we make this request using AJAX on the client side, then that AJAX request is essentially our long poll request, which is going to block and wait for this list item to become available. All right, so now let's look at the client side to see how this works. On the client side, we're just going to randomly generate a poll ID, and we'll come back to this thread in a second. And then down here in the JavaScript, what you can see is we have our poll ID in the JavaScript. I'm just crossing over that client-server boundary here. I'm going to initiate the long poll, and I'm going to tell it to make up to 5 long poll requests in series, just so we don't indefinitely hang against the server. And if it comes back, we just output the response. Otherwise, we output an error. So let's look at what long poll is doing. Long poll is going to be using the async keyword to make this super straightforward. We tell it to run a maximum number of times. In this case, we're saying 5. And because I'm using the async, I can use a basic for loop from 1 to 5 essentially. And inside of that for loop, I can await a fetch request. So the fetch request typically returns a promise, but because I'm inside of an async, I can simply await for it. And if the response comes back okay, I'm going to return the JSON. Otherwise, I'll return an error, which will essentially cause this promise here to either resolve or reject. And let's go ahead and take a look at how this acts in the browser, and then we'll go look in that thread. So if we jump into the browser and let's reload, you can see here we have a polling request stuck in a pending state, right? Because it's going to hang up to 3 seconds. You can see 3.3, another one, 4 seconds. And then eventually we come back with 200 OK, and you can see here's the long poll response, right? And if we scroll up here, you can see long poll attempt 1 got the 404, long poll attempt 2, 404, long poll attempt 3. Eventually, that blocking list operation on the server, right? If we jump back over here, this is blocking for 3 seconds at a time, which is why we're seeing these 3-second times here on the 404 responses. They blocked for 3 seconds, but they didn't have anything in the list. So this comes back as null, which is why we return the 404. But eventually, on the third attempt, you can see we get a 200, and here you can see the status of the job. So job ID 4, status done. This is just hard-coded. It was junk. But where is that junk coming from? Well, now let's look at that CF thread, because that's what we skipped over at the top. So if we jump back here into our browser code, again, this is the poll ID and we're long polling against that poll, but when do we actually set the poll ID? Well, that's that thread at the top that we skipped over quickly. We're using the long polling to check against a theoretical asynchronous background task. We don't actually have a background task in this demo, so we're just using some sleeping for 8 seconds here to simulate some sort of background task. So I'm passing in that poll ID to my asynchronous thread, and then again I'm using that little Redis Gateway to create that list key, which is the same list key that we have here. So here inside my asynchronous thread, I have my poll ID, I have this list item, which is what we're seeing in the console log, right? It's just hard-coded, it's not really the point of the whole thing. And then what you can see is I'm right pushing onto that list this JSON payload here. And then I'm also telling that list to expire in 60 seconds. Now I'm doing this inside of a multi, and that's really important here because we don't ever want to push a value into Redis without telling it to expire if it's supposed to be a transient value, right? If it's a value that exists forever, we don't have to have it expire. But what we never want is to push something into the database and then have, for example, the thread crash or the server to shut down, and for us never to get that expire in there, and then that key ends up living forever. So we're creating a multi operation here, which creates an atomic transaction, which means that the write push and the expire either all complete or they all fail, and that way we can ensure that even if nothing ever blocks and listens for this list item, it will be expunged from the database, from the Redis database within a minute or so, depending on how the algorithm works under the hood. So that's all there is to it. So again, let's just see it in action one more time. We'll refresh. We can see we're doing the long polling. It's blocking. It's that blocking left pop in Redis, blocking left pop, and then eventually we complete. So we're kind of getting the benefits of the long polling in that we essentially, the benefit here is that the moment that list item is available, this request completes with this payload. So as opposed to a regular polling operation, which might be powered with something like a set interval or a set timeout, where we only check the server every 3 seconds, 5 seconds, whatever it is, there's that time in between the interval where we don't actually have any values. The benefit of the long polling is that we're hanging between those intervals, and then at the moment that value becomes available, our polling operation returns. So we get that immediate feedback. And just for completeness, let's take a quick look at the Redis Gateway because I think it uses some interesting Lucee techniques. Here's my Redis Gateway, and one of the things that it does, which is I think just one of the most exciting features of Lucee CFML, is the ability for me to take a bunch of jar files and then load Java classes based on those jar files. You can see I have this load class method here, and I'm passing in Redis Java files, Java class names, and if we look at load class, it's using that collection of jar files with the create object to instantiate or create those classes using those jar files. So we can do this without having to load jar files into the main Lucee libs directory, and that way we don't have any possibility of conflicts with existing class names at different versions and so on and so forth. So I absolutely love that about Lucee CFML. Another cool feature that we're using here is we're passing in that callback, and we're using that to obtain a resource from the Redis connection pool, and then we're passing that to the callback. And then of course you can see we close the connection pool here using the safe navigation operator. Again, just like another really cool feature of Cold Fusion. So anyway, just a fun mental exercise, a nice thought experiment here. I'm not necessarily saying that you should use long polling. Again, there are dangers to using long polling, but I'm always looking for new ways to use Redis, and it occurred to me that I could use the blocking list operations in Redis to power long polling. So again, just a fun thought experiment.